Welcome to Section 5.7. In Section 5.7, we'll be looking at scatter plots and trend lines. For a warm-up, I want you to create a scatter plot. A scatter plot is a graph that relates two sets of data. So to do this, we're going to plot each ordered pair on the graph to make a scatter plot. So go ahead and plot those 4 points. Let's see how your scatter plot should look. Plotting those 4 points, remember you start at the origin. For the point 2, 3, 2 is the x number, so you come over to 2 and then up to 3. For -1, -2, you go -1 on the x-axis and -2 on the y-axis. 0, 2, you don't move at all on the x-axis, you just go up to the 2, and then -2, 0, you move -2 and do not move up or down any. This would be your scatter plot for this data. Our vocabulary word for this section is correlation. A correlation is a measure of the strength of the relationship between two quantities. We're going to look at different types of correlation. We have positive correlation, negative correlation, and little or no correlation. And underneath each of the positives and the negatives, we have weak and we have strong correlation. This would be a sample of a strong positive correlation. This would be an example of a weak positive correlation. Notice it's not as tight and increasing as this one. It's more spread out, but it's still increasing in general. Negative correlation would be decreasing from left to right. And again, notice that this would be strong negative correlation versus weak negative correlation. Again, you notice that it's generally decreasing, but it's not as tight as the strong negative correlation. And then little or no correlation would look like this. It's not really increasing, it's not really decreasing, it's just kind of everywhere. So those are the different types of correlation. We're just going to focus on positive, negative, or none. So let's take a look here. What type of correlation do you think this first one has? This one has negative correlation. How about the second one? Good, positive correlation. And how about this last one? This one has no correlation. Go ahead and look at these 3 and see if you can figure out what type of correlation that each one has. In this first one, you notice that it's increasing from left to right, so therefore that's positive correlation. The second one decreases from left to right, that is negative correlation. And the last one, there is no increasing or decreasing, so it's no correlation. So, we are going to make a scatter plot of the data that's in the table. We are going to let x equal the dollars spent, and that means y must equal gallons bought. So we're going to use that data to make a scatter plot. Notice your scatter plot, you label your x-axis, you label your y-axis, and you also pick your scale. Now they counted by ones on the x-axis, and they counted by halves on the y-axis. Once you do the scatter plot, you'll be able to see whether it increases or decreases and whether it has a positive or a negative correlation. Your scatter plot should look something like this. Quiet. Stop it. Leave it be. So, your scatter plot should look something like this, just plotting the points. You'll also notice that you do have to estimate. We don't have an exact 2.8 on here, so we'd have to estimate that as best we can. So the number of gallons bought increases as the number of dollars spent increases, so therefore this would be a positive correlation. The other thing we're going to do in this section is come up with a line of best fit, also known as a trend line. That's a line on a scatter plot drawn near the points that shows a correlation. When we draw a line of best fit or a trend line, we want to make sure that we have about the same number of points above the line as below the line. And we do also want some points on the line. So for example, we have a scatter plot here. If we look at our trend line here, if I can find where I hit it. There it is. And if we see our trend line here, do you think that this would be a good trend line for this data? Hopefully you said no, because this data here, all of the data that's not on the line is up above it. So we really don't want our trend line here. We would need to move this so that we have some of our data on the line, some of our data above the line, and some of our data below the line. So this would be a better fit for this specific group of data. Here's another example. We're going to make a scatter plot, and then we're going to come up with a trend line or a line of best fit. We're going to also come up with the equation of the trend line. Remember, when we have an equation, we need points and we need slope. That's how we come up with our trend line equation. So go ahead and make your scatter plot for this data, and then see if you can come up with a trend line. So here's the scatter plot that I created, and there's my trend line. I tried to have some data above the line, some data below the line, and some data on the line. Then I chose 2 points on the line. I chose the points 6 and 22.2 and 4 and 16.7. First thing I have to do is find my slope using my slope formula. y2 minus y1 over x2 minus x1. I came up with my slope as 2.75. Then, since I have points and slope, I used point-slope form. You can pick either equation here, and we want to go ahead and substitute in our values. So y minus 22.2 equals 2.75 times the quantity x minus 6. Distribute your 2.75, add 22.2 to both sides to get this to slope-intercept form, where we have y equals 2.75x minus 5.7. Now, don't think that this is the only answer for this particular problem. There are many different possible solutions for. So, as I was saying, this is not the answer for this particular problem. This is just an answer. As long as your equation is something close to this, then you are correct. Your homework for this section is to complete the packet.